You've almost certainly heard the term model before. A great variety of disciplines, from software development to psychology to mathematics, use the term in varied and nuanced ways. Modeling is central to our focus of building domain models and event sourcing, so it's important to understand the nature of modeling. Now, we're definitely not going to explore every meaning of the term, but let's cover those that are the most relevant. In its purest form, a model is an understanding, a conceptual map. When we talk about how we perceive and think about something, we're expressing how concepts are arranged in our mind to create that understanding. The way that these concepts are arranged and interconnected is our mental model. We can use our mental model to make more informed decisions, leading to beneficial outcomes. When two developers discuss how to solve a specific problem, they're comparing and contrasting multiple models. For one, they each possess a different understanding of the problem that needs to be solved. It's not difficult to imagine that two people tasked with solving the same problem might have different views of the precise nature of that problem. Additionally, they might each possess their own understandings of how the problem can and should be solved. Their models of the solution will take many things into account, including the amount of time it would take to implement, the cost of materials, side effects of their proposed solution, and more. But models aren't actually limited to individuals. For example, teams and businesses are made up of individuals, but there are also organisms with their own models that are aggregations of the models of their decision-making parties. In this case, it's unlikely that any one individual possesses the entirety of the model. Bits and pieces live in each person's mind, but they combine together to make a group understanding. Mental models, whether individual or shared, are an important component in software design, as it is this sort of model which represents the features and approaches that result in actual business functionality. It's important that the developers understand the model because it's the model in the minds of the developers, not in the rest of the business, that actually gets turned into software. You might also have heard the term model used when referring to toys and replicas, for example, model cars and model trains. A model car might differ from a real car in many ways, but ultimately it's a simplification of the full form and function of reality. Now, that's not to say that they don't have a purpose. A model car can be valuable in many ways. It can be used for imagination, education, aesthetics. It's providing value despite being a reduced form of the original. When designing a model, we pick and choose the ways in which it resembles reality based on our goals. It's not only the resemblance to the original concept that makes these models useful, it's also the reduction. The fact that unnecessary attributes have been removed actually makes these models more useful for their intended purpose. If I want a toy, I don't need to include features in a model train that aren't relevant for play. When we build software, we're using our understandings of the problem to create solutions. The solutions don't contain wisdom about the entirety of all of the problems that the businesses face. Rather, we focus on the parts that are specifically relevant to the component that we're building. So, our software designs are directly based on our business's understanding for solving its problems. When we create these solutions, we focus on only the parts that are relevant to the solution, and we reduce reality even further from our mental model to provide a model that has more value to us, more value when we're creating an automated system that's designed to solve a problem. The statistician George E.P. Box stated that essentially all models are wrong, but some are useful. So what does this mean? A model by definition is a simplification of reality. Therefore, it can never accurately represent reality. But despite the fact that it will always be inaccurate, it's quite possible that we can still utilize the model to provide value. And indeed, that's exactly how humans have discovered and progressed all technology, by utilizing wrong models. So if models are the stuff of thoughts, then why do web development frameworks so often come with a models folder? The creators and users of these frameworks have understandings of how an application will be built using these tools. By virtue of creating conventions, these tools are opinionated. It's important that we strive to understand these opinions. We don't understand our tools unless we understand the philosophies leading their design. When a models folder is present, the intent is that you create a number of classes or structures that represent the concepts that you'll be working with. These concepts, known as domain concepts due to the relevance to the domain, will contain data, behavior, or a combination of the two. These codified forms are themselves known as models. Now, this is a related but different term to the way that we were using model before. In the previous context, our models were mental maps, concepts connected in our minds. But here, the models are code. In the context of frameworks, they're almost always the result of representing these important business ideas using objects. These objects are often, though not necessarily, tied to the idea of data persistence. This is one form of the word model. We're not talking about a network of interconnected thoughts. We're talking about an object that represents ideas from that mental model related to a single topic. Many frameworks centralize the idea of a model around data persistence. The idea is that the model primarily exists as a schema in the database. Then, these models directly represent individual records in the database and contain some behaviors in the form of methods. Despite the fact that this use of the term model is well established, it's not something that we'll be focused on. This is just one of a number of very valid forms of the term model. But our primary focus is on the concept of a domain model. In our context, a domain model is the combination of objects that represents domain concepts and the way in which they interconnect. The concepts that are important to our solution are encoded and expressed in our programming language. We utilize the natural tools of the language like classes, namespacing, field visibility, constructors, type hinting to express domain concepts. We're going to go over many examples of modeling concepts into code during the course. But for now, the important idea is that the model is focused on domain concepts with as few technical implementation details as possible. When implementing the domain model pattern, we can utilize a layered architecture to separate the domain concepts and the technical implementation. This brings many advantages. The most obvious advantage is the ease in which your team can keep up with the changes in the business. When your code is a reflection of the business's conceptual map and the business's understanding about how things are done changes, then the nature and scale of the change in your code tends to directly reflect the change in the business's mental model. It's a powerful concept. So, a quick recap. The most used definition of a model is as a conceptual map, a mental model, that is an understanding of the domain. How you perceive something is a direct result of your model, and your model directly informs your decision making. A model can also be individual structures or objects that in some way exist to represent concepts relevant to the conceptual understanding of the developer or the team of developers that's creating it. In this form of the term, these models are often data-centric and focus on schema in a database. Finally, a domain model refers to all of the domain-oriented code in your application. It's the codified version of the mental model that your team has determined is the appropriate solution. We can build a domain model as a separate layer in our applications so that the technical details can be separated from the domain concepts. This allows the source code to most directly reflect the mental model of how to solve the problem. Implementation details like persistence are relegated to a different layer of the application architecture and are often designed separately from the model. So you can see why people often say that model is one of the most overloaded terms in software design.